Yo, Coach Ray here, continuing our piecewise notes. We're going to do example 2 in the graphing piecewise notes. We did number 1 in the last video, so there are multiple piecewise videos. All right, here's example 2 in the graphing piecewise notes. Same idea, it's just going to end up looking a little bit different. One thing that's different here is clearly there's more pieces. We've got like 5 different pieces here, where before we were only messing with 3. But still, the idea is still the same, that we're graphing this line, y equals -6, only in this section where the boundary tells us. So we're only graphing y equals -6 in between -6 and -4. All right? It ends up looking kind of cool. But one major key here is you have to remember what a line looks like if it's just y equals a constant. Okay, if you have y equals just a number or a constant, then we have a horizontal line. All right? So if I just graphed f of x equals -6 into Desmos, I would get a big old long horizontal line down here at -6. So we're going to graph that. We're just only going to do it in the little section between -6 and -4 on the x-axis. Okay? So let's do this. I know I'm only going to graph it between -6 and -4. So on the x-axis, I'm counting backwards. 1, 2, 3, 4, 5, 6. Okay, and I'm going to come down. 1, 2, 3, 4, 5, 6. So my horizontal line is right there. It's only a small little chunk because I only went from -6 to -4, left and right. All right? The only other part that you need to have down here is the whole open dot versus filled in dot thing, and that really just comes from our greater than or equal to's versus just the greater thans. Okay, so in this top function, it says x is greater than or equal to -6. So on the -6 side, I need a filled in dot. On the right side, it says x is less than -4 without the equal sign underneath. So that's going to be a filled in dot. Okay, just to relate this back to previous videos and previous notes, if I asked you to evaluate f of -4, you would have to look to see which line this is going to go into. And here, when it says x is just less than -4, -4 is not less than -4, so you would not use this top line. Here, -4 is greater than or equal to -4, so you would use this middle line. So that's why we're getting the closed dots on the ones where it's included. Okay, so this one we left it open because it's not in this top line. All right, next one. I can move a little faster now. Y equals -4, horizontal line down to -4, and I'm only doing it from -4 to -2. Okay, so I'm coming down to here. There's my horizontal line between -4 and -2. Same thing, I've got the equal sign on the left side and the just the less than on the right side. And as I come to look, all of them have the equal sign on the left side, so they're all going to be the same. All right, next one, I'm doing y equals -2 in between -2 and 0. So I'm coming down 2 spaces, and I'm just doing it between -2 and 0. Okay, this one gets the closed one, this one gets the open. All right, next one. I got y equals 0. That's going to be right on the x-axis. On the x-axis between 0 and 2 right there. So again, filled in on the left, open on the right. Okay, last one. Y equals 2, so I'm going up 2, and I'm only graphing that between 2 and 4. So that's going to go from here to here. Filled in dot on the left, open dot on the right. Okay, I bet you can guess what the name of this function is. It is a piecewise, but it's got a specific name. Any guesses? Huh? No. What does it look like? Steps. It is a step function. Okay, so like majority of piecewise functions that we're going to mess with are going to be like these ones, where we've got just 3 random lines. Doesn't look like anything fancy, but I do want you to see these pop up every now and then, where we can make piecewise functions look like steps, and this is called a step function. Okay, that is it for the graphing piecewise. So we've got example 1 and example 2 done. There will be one more video coming, and that'll make up all the piecewise videos.